All right, today we'll look at code. So the first thing we'll look at is shape, which is at the top of our hierarchy. So public, abstract, shape. So remember that an abstract class is in between a concrete class and an interface. So an interface, only abstraction. But an abstract class can actually have some implementation if you know how to do it at that level. So remember, we're still thinking at a very general level when we're talking about abstract classes, so we don't know everything about it. So in this case, I've moved the implementation of drawable and printable, which remember are interfaces, into the shape class. So those are interface methods. Let's review what they are. So drawable says I have a method called draw. Again, at this level, we don't know how to draw the shape, but we do know the idea that we are drawable. Same thing for printable. We know we have a class that we want to be able to print, but we don't know how to do it yet until we know more about it. So both of those are implemented in shape. Now, this is an abstract class. So if it didn't have the keyword abstract, so it's a concrete class. If it doesn't have the keyword abstract, then the compiler would make us implement at this level the draw and the print methods that we have promised in the interface. Because we're an abstract class, the compiler doesn't insist on it. So we have a new notion here, the idea of getArea. And this should really drive home the idea of abstraction in object-oriented programming languages. You have the idea of a closed shape. Therefore, you have the idea that that shape has an area. But until you know more about the shape, that is, what's the geometric shape, then you don't know the math necessary to calculate the area. Here, we also have, so this is just an abstract method. Here, we also have a concrete method here. So an abstract class is a mixture of abstraction and concrete. So we have this method called printArea. So it says I am a super. So super refers to the base class of the current class shape. What's the base class? All classes inherit from object in Java, even if it doesn't explicitly interface. Even though it doesn't explicitly inherit from object, the compiler puts that inheritance in there for you. So when you do super, you're referring to the base class, the super class. So it has a method called getClass, and that will return the name of the current class. And then we also have a toString method, so it'll convert the class name into a string so we can print it. I'm a whatever class it is, toString of area, and then we call the getArea that we've just defined here as an abstract method. So moving on from that, we have circle. So circle now, notice the keyword extends here. So if you're extending a class, but you implement an interface. So since shape is an abstract class, but a class, we extend it. So remember, shape also implements printable and drawable. So that means one level up from shape, we still have printable and drawable. So circle is a shape, but it also is a printable and it is a drawable. In extending shape, we need to implement any type of abstract method that shape defined. And the abstract method that shape defined is getArea. So here, and the compiler would fuss at us at this time if we didn't have it. So we have it, so the compiler's not fussing at us. Notice too, we know we're a circle, therefore we know how to calculate the area. We have this private property called radius that's set in the constructor. So you should know that is an example of encapsulation. Private properties, public methods to manipulate those properties according to how the class designer thinks it should work. We implement getArea. We know we're a circle, so we have the, I hope, correct arithmetic to calculate the area of a circle. Pi times radius squared. So I use the math class for helper methods there. Rectangle is very similar. It's a concrete class that extends shape. So it has a constructor that takes width and height, not just one, which is radius of a circle. We implement printable. We actually don't need to do that here. We do need to do that here. And drawable. And we have our concrete get area method that knows the arithmetic necessary to get the area of a rectangle. So concrete, once we're down at that level, we know how to implement the idea that was just a general idea before. In our test driver, so now I've changed this. Before it was declared as one of the interfaces. Now I'm declaring it as a shape, even more general. So I declare it as a shape. I instantiate or create a circle object. Then we do a print area of the circle, and then we do print our own method down here that's printable, and we print as a shape. All of this is, when it runs, is going to be an example of polymorphism. So we expect when this shape is instantiated or an object is created as a circle, that print area will behave as a circle. And then when that very same shape handle is instantiated as a rectangle, that print area and do print will behave in a way that's appropriate for a rectangle. Polymorphism, many forms. So I'm a circle of area, and I print a circle, and I'm a rectangle of area 6. Print a rectangle. So polymorphic here. So let's review that method, print area, that we defined in our abstract class shape. Okay. So print area, concrete method. It knows the class name. I am a circle of area. And here's where polymorphism comes into play again. Get area. That was defined abstractly here, but when the actual object is created, it knows which method to call. That is circles area, and when it's a rectangle, it knows to call the rectangle area. So we have encapsulation. The data is private. The methods are public. We have inheritance. We have polymorphism here. And we have the notion of abstraction here. The 4 characteristics of object-oriented programming languages as illustrated in Java, a fully object-oriented programming language. Very powerful notions.